Okay, good morning, everyone. So today we are going to continue our lesson. Okay, so the learning standard for today is solve problems involving systems of linear inequality into variables. Okay, so for this one, you might need a graph paper. Okay, especially uh, for the question that you will answer later. Okay, so for this one, let's look at, okay, I will straight away go to uh, example 14. Okay, I will straight away go to example 14. All right, so let's look at example 14. Okay, so Madam Carol needs to select at most 20 pupils for choir competition. The number of girls is at least twice the number of boys. Okay, so the first question you need to write two linear inequalities other than x is greater than or equal to 0 and y is greater or equal to 0. Like I said before, this number, okay, this inequality, we always have this because, okay, x and y, they are representing the quantity, so it will have to be greater or equal to 0. Okay, which represent the conditions of the selection of the competitor. Okay, so the second one, you need to draw and shade the region that satisfy the above system of linear inequality. All right, so from the graph that you draw later, you have to determine the minimum and maximum number of girls when the number of boys is 5, and then determine whether the condition of the selection are ahead to if 8 boys want to participate in the choir competition. Justify your answer. Okay, so to answer this one, you need to first draw two linear inequality. Okay, so the two linear inequality that we can get. Okay, the first one, let's say our we represent, okay, our girls and boy with x and y. Okay, okay, let's say our girl is x and then boys is y. Okay, so you can say here x plus y is less than or equal to 20. Okay, because it say here at most 20 pupils, meaning that the maximum is 20. All right, and then the second one that you can get is the number of girls is at least twice the number of boys. Okay, so meaning that your x is greater or equal to 2y. All right, or you can write like this: 2y is less than or equal to x. Okay, you can just rearrange it. Okay, so if you see here, okay, the point here, make y the subject of the formula so that the region can be marked correctly. That is why we always put our y at the left hand side, or we call it as a subject. All right, so now you already have these two inequality. So in an exam you get 2 marks for this one. Okay, so actually we have 4 inequality here: 1, 2, 3, 4. Okay, so the next question, you need to draw and shade the region. Okay, so first you need to, all right, first you need to uh, draw your x-axis and y-axis. There is no scale for the axis. It's just that you have to look at the question lah. Okay, maybe you this for this one you can use 2 cm to 5 units, all right, in your graph. Okay, so you already have your x-axis and y-axis. So your x-axis is your girls, and then y-axis is the boy. Okay, so you have to draw a straight line from this inequality. Okay, so you have a straight line here, y plus x plus y is equal to 20. So you need to draw it, you need to have at least 2 points. So the first point, you can substitute x with 0. So your y is equal to 20. And then the second point, if you substitute your y equal to 0, your x is equal to 20. And then you make a mark there. Okay, x 0, y 20. So make a mark there. And then x 20, y 0. Alright, so after that you make a straight line and label your line. Okay, so this one, okay, is less than or equal to. So you will have a solid line. Alright, and then the second one, 2y is equal to x. Okay, so if you substitute your x with 0, your y is automatically 0. Okay, and then if you substitute your x with um, 20, okay, your y is equal to 10. Okay, so the 2 points that you can get is 0, 0 and 20, 10. And then um, you use your ruler to connect the line. Okay, so this one you label as 2y equal to x. Okay, so now you already have two lines. All right, so it wants you to shade the region that satisfied the above system. Okay, so if you see here, okay, you have uh two lines. So how are you going to shade the region? This one you already learned yesterday. Okay, so we have x plus y is less than 20. So this is your straight line x plus y, okay, less than 20, meaning that you are going to shade the one below. Okay, so this one, you're going to shade this one. Okay, so I just make a mark there. And then the second one, 2y is less than x. Okay, so 2y is this straight line. Okay, less than x, also below. So below, okay, we are going to shade this part and this part. So if you see here, we have a common area to be shared. Okay, or we can say there are intersection between these two inequality. Okay, so oh yeah, before that, your x is greater than 0. Okay, of course, to the above side, and then y is greater than 0, also this side. All right, so all right, so if you see, the intersection is at this one, at the yellow, not yellow, green region. Okay, this one. So these are the shaded region. Okay, so after that, okay, after you get the one, your region, you can erase the mark here. Okay, the mark here. All right, so you just shade this part. Okay, you just shade this part. Okay, so that one is B. Okay, so C, you want to, okay, from the graph, determine the minimum and maximum number of girls when the number of boys is 5. Okay, so you see here, if we have the boys 5, what is the minimum and the maximum number of girl? So if the boys is 5, okay, you take your graph and then look at the minimum point at the region, shaded region. What is the minimum point of y here, x here? Okay, 10, right? Okay, 10. So minimum, meaning that if there are 5 boys, okay, our minimum number of girls is 10. And then the maximum will be the furthest one. Okay, here, that is 15. Okay, so if your boy is 5, your girls will be, the minimum will be 10 and the maximum will be 15. All right. Okay, and then the next question, determine whether the condition of the selected are adherent to if 8 boys want to participate in the choir competition. Okay, so 8 boys, okay, so 8 boys is somewhere here. Okay, somewhere here. So if you see at boys, okay, okay. So is it possible for at boys to enter the competition? No. Why? Because the value y equal to 8 is outside of the shaded region. Okay, it only apply um if it is inside of the shaded region. Okay, so this is example 14. All right, so let's look at example 15. Okay, example 15, the maximum number of passenger on a train in a theme park is 30. As a security measure, the required number of adults is always greater than or equal to the number of children. Okay, write two linear inequality other than x equal greater than 0, y greater than or equal to 0. So here, okay, we assume that, okay, or we have two types of people. First is the children. The children we let it be x, and an adult will let it y. All right, so it says here the maximum number is 30. So meaning that x plus y is less than or equal to 30. Okay, that is the first one. This is the first one. And then the second one, it says here the number of adult is always greater than or equal to number of children. So meaning that y is always greater than or equal to x. Okay, this is the second one. All right, so after you get that one, okay, this is 2 marks already. And then the second one, you have to draw and shade the region that satisfy the above system. Okay, so after that, you need to draw a graph. Okay, so you need to draw a graph. Okay, you just draw the Cartesian graph, Cartesian plan. Okay, x and y. Your y is your adult, x is your children. All right, so in this one, they use 2 cm to 10 units. All right, so x plus y equal to 30, you substitute, you want to draw a straight line. If your x equal to 0, your y equal to 30. If your y equal to 0, your x equal to 30. So you have 2 points here, that is 0, 30, and also 30, 0. All right, and then you make a straight line and then label it. And then the second one is y equal to x. So if your x equal to 0, your y equal to 0. So 0, 0. And then if your x equal to 30, okay, your y equal to 30. Okay, if you want to choose other number also can. Let's say if you want to choose your x equal to 20, then your y is also 20. Okay, so this one, we choose for this one, we choose a simple one, easier for you to calculate. Okay, so if you see here, okay, you already draw, and then you are going to shade it. Okay, so how are you going to shade it? All right, x plus y is less than or equal to 30. So less than meaning that you have to shade below. All right, and then the second one, y is greater or equal to x. So this is your straight line. Okay, greater than meaning the above. Okay, you have to shade the one above. So you shade this one and this one. Okay, and then x is greater than 0, y is greater than 0. So it should be on the right side. Okay, so if you see here, the intersection is this one. So this is the region that you should shade. All right, after that, okay, the question, from the graph, determine the maximum number of children that is allowed to board the train. So the maximum number, okay, this is the adult, right? Okay, the furthest point for the shaded region is this one. So if you see, this one is, what is the value of x? X is the children, right? 15, right? So meaning that the maximum number of children is 15. Okay, and then the second one, If there are 18 children, can all the children board the train at the same time? Justify your answer. Okay. So if 18, can they all board at the train at the same time? No, cannot, because you see 18 is outside of the shaded region. Okay, like we said just now, the maximum of children is 15. Okay, all right. So that's it for this one. Uh, the question. So actually, it's not that difficult. It's quite easy. Okay, so maybe later you can try. Okay, you can try to do question 2C, and then question 3 and 4. So these two question 3 and 4, you need to have your graph paper and you draw in your graph paper for question 3 and 4. Okay, so after that you need to uh, upload your answer in a Google Classroom by today. Okay, so that's it for the lesson today. Thank you very much.